8.4, use scientific notation. Have y'all done scientific notation in any of your classes yet?
Does geometry dash count?
Huh?
Does geometry dash count? It's a video game.
Yo.
Wait. What is scientific notation?
Okay. Well, when I explain it, you can tell me if you've seen it before. If you've done it, it would only have probably been in science class up to this point.
I've done it. It's
But-
hard.
I have not even heard this before.
That's okay. I'm assuming that you haven't, but I was like, sometimes I don't really remember what all is in middle school science, so who knows? Maybe you have used it before. I don't know. Basically, scientific notation is going to be a way that we can write really, really big or really, really small numbers in a way that's easier to understand. Scientific notation. A number is written in scientific notation when it is of the form C times 10 to the n, where 1 is less than or equal to C is less than 10, and n is an integer. Okay, so basically any number. So C, the number in front has to be a single digit number, is all that's basically telling you. It's got to be a whole number, basically 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, it sometimes will end up being a decimal, but we'll talk about that. But anyways, it can't have more than one number in front of the decimal. That's the way I'll put it. So, if I had the number 2 million, so 2 with 6 zeros, obviously that's a pretty big number to have to write. But I could write it in scientific notation, so this is standard form, but in scientific notation, as 2 times 10 to the 6th. So the way we do this is we start right now, every whole number has a decimal at the end of it. Okay? And so all we're doing is we're taking it and moving it to the left, and we count how many spaces. So 1, 2, 3, 4, 5, 6. And we moved it here, so there's one number in front of the decimal. So I moved it 6 spaces over, so that's where the times 10 to the 6th comes from. Okay, so that's if it's a really big number, we move the decimal from right to left, and it gets a positive exponent. Okay, the other option, though, if we have a really small number, something like 0.0005, would be written as 5 times 10 to the negative 4, because what we want to do is we want to get that decimal to the right-hand side of my first, whole number that's not a 0. So I'm going to take this decimal, and it moves from left to right, which gives me the negative exponent. So it goes 1, 2, 3, 4, and I put it there, and so this becomes 5. And then times 10 to how many spots I moved it to the right, and I moved it 4, and so it gets the negative 4. So if it's a small number, then it has a negative exponent. If it's a really big number, it's a positive exponent. Okay? And this stuff will be really, really important as you get into science next year, physical science. This will start to be a really big factor that you have in there, is using scientific notation for things, because you'll learn about, this is getting way ahead, but significant figures and how many things you have to make things in the proper form and all of that. So, anyways, there's that for you. So jumping right in, the first step that they want us to do is simply just to write the numbers in scientific notation. So write the number in scientific notation. And there's obviously more we'll do with these things as well, but that's just the first thing we need to know how to write it first before we can do anything else. All right, so number 4, we have 0.72. So the decimal's on the left. I need to move it to where there is one single digit on the left-hand side of that decimal. So I'm going to move it one spot here and put it there. So this becomes 7.2 times 10, and it's going to be, I moved it one spot to the -1. So if you move it to the right, it's a negative exponent. If you move it to the left, it's a positive exponent. Number 6 is literally this example that I already did for you, so I'm just going to skip that one and jump to 8. Number 8, 0.00406. Just realizing this is going to be a problem for some reason. Literally all of the even ones are this kind and all of the odd ones are the other kind. So we're going to do a few odd ones and you're going to get a few even ones in your homework. All right, so this one, I need to get it to the right of, so that the whole number is on the left of the decimal. Sometimes what I do is I'm going, okay, I know the decimal needs to get here. And so then I just go, okay, how many do I need to move it? 1, 2, 3. And so this would be 4.06 times 10 to the -3. Let's see, 9. So like I said, I'm going to have to do a few odd ones so that you get both. We get to do a couple examples of both. It is 1,065,250. Let me rephrase. 1,065,250.
What if we move the decimal to be right after 1?
Yes, that is what I'm doing. All right, so right now the decimal, there's an imaginary decimal right here, okay? But I need to move it so that the only thing is this 1 before it. So I'm moving it back this way. So 1, 2, 3, 4, 5, 6. So this is going to be 1 point, and we write all the numbers until all that's left is zeros. So this is going to be 1.06525, and then times 10 to the +6 because it moved to the left. See, one more of these ones, and then we'll be working the opposite way, where they'll give us what I have in red, and we're working toward what's in black. So 13, I'm not even sure what number this is. 900 000 000 000 000 000.
900 trillion is crazy.
Wait.
It's trillion.
I think that's more than a trillion, but maybe not.
No, that's 900
That's
trillion.
900 trillion.
Okay, anymore.
Cookie point?
How is that a cookie?
No, that's
She
a
said she
cookie
didn't know
point.
what it was.
It's a cookie point.
She didn't know what it is.
It's not a cookie point. There's
she
not
said
a
she-
mistake
yeah,
there.
She didn't make a mistake.
All right, so there is an imaginary decimal sitting here at the end. Where do I want to get the decimal to? Right after the 9. So, this is going over 1, 2.
3, 6.
What just happened?
What the?
Huh?
Y'all saw that too,
How
right?
counted
Yo,
were
what
you?
the?
What just happened?
4, 5, 6, 7, 8, 9, 10, 11.
I don't even know how that just
3,
happened.
6, 9,
14.
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this becomes 9 times 10 to the 14th.
Oh wow. Oh, that's fun.
That's not hard, is it?
Let's wait till we get to
Yay.
quintillions.
Quintillions. That's like.
Quintillions.
No, that's another zero.
I can't-
That's
Now,
another
you
zero.
do not have to do these little
Oh.
swoosh things under here. It just helps to count, make sure you get them all. But you don't have to do it that way.
So every time, like, for every problem, it's gonna be the first number times a 10.
Yeah.
Okay.
Because that's basically saying, like, how many zeros we have, but obviously some of them aren't zeros. But that's more or less, like, where this, like, concept came from.
Is that gonna be the biggest number? Because I really hope it isn't.
That's gonna be the biggest number.
In that section, it looks like it is.
Okay. I hope it's not the biggest number. I like drawing big numbers.
All right, the next ones want us to write the number in standard form. So we're going to be working backwards. Okay, good. These ones they mix up, so I can actually do even ones on this set. All right, so number 16, 2.6 times 10 to the third. So I know I have a positive exponent, okay, so that tells me it's going to be a big number, okay, with a decimal at the end. If it is a negative exponent, I know it's going to be a small number with the decimal at the beginning, okay? So in a positive exponent, on the ones that we're moving to standard form, the decimal goes the same direction as, like, going to the right is positive, going to the left is negative. So what I would redo is I would do right down here the 2.6, and then I'm going to move it over 3 spots. So 1, 2, 3, put the decimal there, fill in the zeros. So this number is 2,600.
Yippee!
Oh yeah, let's look at that too.
And you don't have to have it with the ones that are like whole numbers like this. If they're decimal numbers, obviously we've got to have that decimal at the beginning. Let's see, 18. 1.11 times 10 to the second.
Alright.
So this one, and again, I'm just rewriting it. You don't have to rewrite it. You can just do it if you want. This is going to move 1, 2 to the right. So this is going to become 111.
You should just give us some homework now.
No,
But
we should not. No,
we
should
are not done.
Oh.
We'd be so cool.
All right, try this one on your own. 20. 4.709 times 10 to the 6th. And you should be putting appropriate commas where they're needed with big numbers. All right, what do we get?
4,709,000.
I'm not saying all that.
Yeah,
No, I'm not saying it because I know I'm gonna butcher it.
Yep, 4,709,000. So 4,709,000. So I had to add 3 zeros to the end of it. All right, so those were all positive exponents. It moved to the right for standard form. 22, 6.1 times 10 to the negative 3. So when I'm going from scientific to standard, I move in the same direction as my exponent. So that means this is negative. I'm going to the left. So I'm taking this and going back 3. So 1, 2, 3. And I have to put the decimal this time. Fill in the 0. So 0.0061. Do we like this stuff?
Oh,
Yeah.
yeah. So easy.
We went from calculus to
That was not calculus.
Calculus to algebra 1. That was
That
not
was not
calculus.
calculus.
That
Yes, it
still
was.
called algebra
Yes, it
1.
was, bro.
I'm pretty sure calculus is worse.
We don't like this
2.23 times 10 to the negative 6. What do I have to do with this one?
Decimal back 6.
To the left 6. So 1, 2, 3, 4, 5, 6. Put that decimal. I'm going to fill in the zeros that we're missing. So this is 0.00000223.
This is reminding me of the thing in 5th grade. It's like, what digit is this? Is this the 10th?
Oh, yeah, I remember that.
Bro, I
10,000.
failed that. I don't know what I was saying.
Million.
I assure you I'm not asking you that.
Thank you.
Thank you.
Why? That was easy.
I was like, is this the
This is
thing?
easy.
I was looking at the wrong numbers.
All right, 26. 6.4111 times 10 to the negative 10.
Oh no.
I don't like this.
Oh,
What do I do with this
no.
one?
That's not hard.
You have to move 10 backwards.
It is 0, 0, 0.
Bro.
Shut up. Let the teacher do it.
Yeah.
Back. 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 9 zeros, basically, is what that's telling me in front of my 6. 1, 2, 3. So 0.000000. I'm getting lost. 000 6 4 1 1 1. Always go back and count, right? You don't want to miss, right, a problem by just forgetting to write a 0. So always go back and count. If it's helpful, underline them in groups of 3 or something and get back to, be like, okay, I know the decimal was here, so that's 10 spots. I know I'm good, right? Because you don't want to know what you're doing and just simply forget to write a 0 down and get the problem wrong. All right. So a few interesting ones here. 34.
I put 28.
Copy and paste or copy and complete. We're not in computer class. The statement using less than, greater than, or equal to.
Oh, we're back to this stuff.
Welcome back to chapter 5.
I'm into those.
Bro, not sure.
Can we go back to the easier
What was
stuff?
it?
34. 4004.1 blank 4.04001 times 10 to the 5th.
It's definitely the.
Oh, okay. Yeah. Okay. This is.
So what I would recommend we do is we either decide that we're putting everything in standard form or everything in scientific notation. I would say that you probably will do better if we go to standard form. The one on the left is already in standard form. The one on the right is not. So I would rewrite this one as, it's moving to the right 5. So 1, 2, 3, 4, 5. 404001. So what is this compared to this one?
Bigger.
The one on the
Right.
right is bigger.
Okay, so which of these goes in the blank?
The one that goes
The
in
less.
Less than.
Less than.
I get them confused all the time.
Remember, alligator mouth opens to the bigger one. They want to eat the bigger one.
You just
You
eat
should-
everything.
They needed sound effects. No,
Don't not, bro.
I was like, what was that? Because I was not looking. I was like, I don't know what just happened. All right.
They needed sound effects.
Point 0.03309 blank 3.309 times 10 to the negative 3. So again, I would recommend we write in standard form. I think you're going to do better with that. It's fine if you want to do it the other way, but I think you'll do better overall in standard form. So That being said, what do I do with this one to put this in standard form?
Move the decimal back 3.
Back 3.
Wait, no.
So that's going to be 0.003309. What is this compared to this?
Whoa.
Equals
I love
38. Here we go. 604,589,000. And then 6.04589 times 10 to the 7th. What should I do with this one?
Make it standard form.
Huh?
Make it standard form.
How do I do that?
Move it forward 7.
1, 2, 3, 4, 5, 6, 7. So I need to put 2 zeros on the end. So 6, 0, 4, 5, 8, 9, 0, 0.
That's just weird.
Okay, I think we clearly know what's bigger.
Should I wait more sound effects?
No.
We don't need more
All
sound
right, which one?
Oh.
What goes in the blank?
Greater
Greater than.
Greater than. Look at that. They gave us one of each.
Alright, video.
Bro, there's
I'm
no
waiting for my
way,
sound
bro.
effect.
I was gonna say.
Yo!
Oh, video, do you do ASMR in your free time?
All right, the next thing and the last thing in this section is evaluate the expression, writing your answer in scientific notation.
What's up? What?
I'll do the teacher does.
So you got to make sure in these sections we're paying attention to instructions. Number 40. If you hate multiplying decimals, you're not going to like this part. In parentheses, 7.3 times 10 to the negative 5 times, in another parentheses, 5.8 times 10 to the 2. So, the easiest way to do this is using our exponent rules that we have from the last 3 sections to do this. So, I almost lost my book.
I thought you almost fell. I was like,
no.
Just take a tumble. We're done with math for today. Anyway, so I take the numbers, everything's being multiplied in here, so I'm going to take this 7.3 and the 5.8 and multiply it by each other. So I'm going to have 7.3 times 5.8. Those things are going to get multiplied. Times, now I'm multiplying things that have the same base. What happens when I do that? We add them together, so this is going to be 10 to the negative 5 plus 2. So this is going to end up being times 10 to the negative 3. Obviously, we said in the last section we can't have negative exponents. Scientific notation is the exception to that rule, right? Because that tells us which way our decimal is moving. Now, I've got to multiply 7.3 times 5.8. I feel like this is a good refresher anyways, because I know that's something we can struggle with. So, easiest way to do that is going to be something like this. Set it up to multiply. 8 times 3 is 24. Carry the 2. 8 times 7 is 56. Plus 2 is 58. The next time we put a 0 here. 5 times 3 is 15. Carry the 1. 5 times 7 is 35. Plus 1 is 36. And then we add everything together. So this is 4, 13, 12, 4. Now, the decimal. I had 2 decimal places here, so I take this decimal and I move it 2 over. So this would be 42.34 times 10 to the negative 3. That's not in proper scientific notation. So, what do I need to do?
Put it where it ain't.
We would take it back. We would take it back to negative 3 times. We would take it back 3
move it
times.
forward.
Back one.
Back
I've got to take this and I've got to move it from here to here so that it's in proper scientific notation, which is going to be 4.234 times 10 to the what? What did I do with this decimal?
Negative 2.
It went left, but when I'm doing it this way, standard to scientific, what do?
Do it again.
Add 1. Add 1 when it's going from, if it's easier to think about it, just look at it this way. Let's do this. Let's just backtrack for a second. I'm going to come back over here. 42.34. If I wanted this in scientific notation, I would move it this way, and it would be 4.234 times 10 to the what?
Negative 2.
It just moved one space.
Negative 2.
10 to the 1.
Oh, yes.
Yeah.
Okay, so now I have up here 4.234 times 10 to the first times 10 to the negative 3. Now I'm basically doing the same process I did up here again. So 4.234 times 10 to the what?
Negative 2.
Negative 2.
Why can't we just leave it at
We all heard that.
Because it's
obviously.
not proper scientific notation.
Wait, you can all be talking.
Yes, I can.
Why do you always point whenever you say that? You're like,
Yo, you can be talking.
42.
oh.
But if you
You
say
just want everyone to know that,
6
so it's
times
weird,
10 to the negative 3 divided by 8 times 10 to the negative 6.
You gotta like add. You gotta add 6 to negative 3 because you're moving it up.
Yep, so I'm going to move this to the top. So this would become 10 to the negative 3 plus 6. What about this 6 over 8?
You gotta like make it like 3/4.
Okay, 3/4. It's one way I can think about it. I still need to divide it ultimately. What is 3/4 as a decimal?
0.75.
0.75.
X or multiplications?
Multiplication. Scientific notation is always like an actual multiplication sign.
I've been reading the
So times 10 to the third. Is that in proper scientific notation?
Yes.
No.
Wait, no.
Where does the decimal have to be in proper scientific notation?
Number.
Gotta be a 4 number.
After the 7.
Oh.
It's got to be a number, then a decimal point. Every time. Number, then decimal point. So I've got to move it here. What is that requiring me to do?
You gotta push
10
it.
Times it
negative
by 10 to the
1.
one.
10 to negative 1.
Yep. So this would be 7.5 times 10 to the negative 1 times 10 to the third, which ends up giving me what?
7.5 times 10 to the second.
Yep.
Yeah, that. 10 squared.
Yeah,
Come on,
Care.
John.
Yeah,
I
yeah,
care.
yeah.
I
Yeah,
care.
I care.
I care. We all care. Like Jonathan.
Huh?
Yeah, we all. Oh,
10 to the second.
No,
and
not
10 to the
that.
Oh, we
second.
care. We care. We
Grace
care.
doesn't care.
I didn't even hear anything. I'm so focused on this math, dude.
Oh.
All right, 46. Last one. In parentheses, 7 times 10 to the negative 5. All of that raised to the fourth. I'm actually going to make it, I'm going to modify this and I'm going to make it 3 so that it's easier. So the fourth is just a lot more. So, just like what we did when we had things being multiplied raised to a power, we're distributing that 3 to both things. Okay? So that's going to be 7 cubed times 10 to the negative 5 cubed. When I have a power raised to a power, what do I do?
Multiply.
So that's going to be times 10 to the what? Negative 15.
Wait.
What's 7 cubed?
200. Wait, no. I've done
80.
434. I just do it.
Bro, I don't know.
We did this one the other day. 343.
Dang it, I just did it.
John,
Now,
you messed up
is
that.
this Is this in proper scientific notation?
No.
What do I need to do? Where?
Before, after the three,
After the first three.
So it needs to go here, which would be 3.43 what? Times 10 to the what? Times 10 to the second, times 10 to the negative 15th. Add those together. I get 3.43 times 10 to the negative 13.
I wonder what that would actually be if you actually did
No,
it.
don't even
I
go
don't
there. No,
wanna
I'm
know.
done.
No.
Wait, actually, it's a big number. Never mind.
No, it's a small number.
All right, so problems. We have 20 minutes. You should have plenty of time here. I gotta go back and see which ones we did now since I have to give some random ones. All right, let's see.
We used to work on Disney sound effects.
Yeah,
You would probably get paid good money, dude.
Disney sound effects.
I'm gonna go back and do one more thing really quick here on number 3 because you're not gonna probably have recognized what to do with this one. They give us 8.5, and they wanted it written in scientific notation. It kind of already is, right? The decimal point's in the right spot. So, this is a little bit of a tricky one.
Oh, 10 to the 0.
Yes! It would have been 8.5 times 10 to the 0 because 10 to the 0 is 1. So, that would say the same thing, but this is technically in scientific notation now. Alright, which ones did I do? I did 9 and 13.
I'm
Okay.
not in the right place, dude.
I'm gonna get executed. Tim.
I don't think you're in the right grade, Jonathan. Go to calculus.
He's not supposed to be here right now.
Me.
Watson is
Probably already took calculus. He's just retaking all this class for fun.
He's the third.
He just wants to be with his peers.
Also, I hate the fact that you have to
You
use
know what? I'm gonna just repeat all
yeah.
classes again.
Yeah.
I hate the fact that you have to use
We said Jonathan probably already took calculus. He's just retaking all the math.
Honestly, I'm
Yeah, he just wants to see us all struggle and he's
I would
like, I already know this.
put the decimals on.
You probably just gets like problems.
Yeah.
He's like, you know what? Let's see.
That's
You know, I think they kind of smart like catch on to me. So let's get this
I
one.
don't think I'm good. We didn't say he was an AI.
Like, I might be, I don't know.
Maybe I'm an AI.
Jonathan's a big AI.
We can find that thing right now, you know.
Yeah, maybe I'm an experiment.
Someone created by
I
science.
think Jonathan not
Suppose
tell
I can
us
fix
that.
that shit.
I might be creative. I might be
Jonathan,
creative.
did
in
your
the lab.
creator tell you not to say that?
What?
Did your creator tell you not to say that?
Malfunctioning.
Alright, I know you have a couple even ones in here. It's because either they're easier or there was no other option. But I've tried to pick, like, especially in these last 3, I've tried to pick easier ones for you. Anyways, but you should have time because most of these problems are really quick. Everything should be quick except for the last 3. Those are going to take you the most time.
Wow.